we are going to do Unit 6, Lesson 1. So, please complete the first slide. We'll give you a few minutes to do it. So, hit pause when you're ready, hit play, and assess your answers. Here are your answers assessed. 2 to the 4th because there's 4 2s, 10 to the 7th because it's 10 times 10 times 10 times 10 times 10, 7 times. 4.5 to the 5th and 1/2 to the 3rd. Create your own definition of exponential form. Expanded form is repeated multiplication. The next thing we would like you to do is write the expression in expanded form. Hit pause when you're ready, hit play, and then the answers will come. So we have 5 times 5 times 5 times 5. 6 to the 6 is 6 times 6 times 6 times 6 times 6 times 6. As you can see, I just want to go over the fractional base, 2/5 to the 3rd. And it's 2/5 times 2/5 times 2/5. Create your own definition of expanded form, repeated multiplication. Write each expression in standard form. Sorry about that. So you have 5 to the 4th, 6 to the 3rd, 3 to the 7th, and 1/4 to the 3rd. Hit pause, then hit play to assess your answers. Here are the answers in standard form, and we have 5 to the 4th is 625, 3 to the 7th is 2,187, 6 to the 3rd is 216, 1/4 to the 3rd is 1/64. Create your own definition of a standard form. Standard form is the answer as a number. List the form underneath each arrow. The first is exponential form. The next one is expanded form because it's 5 times 5 times 5 times 5. And the standard form is 625. Now we would like you to substitute the given values of x to complete the table below. And then you have to describe any patterns you see in the table. So this is base 1, base 2, base 3, base 4. And then they have x as the exponent. Well, the x's are 0, 1, 2, 3, and 4. The first line is 1 to the 0, 2 to the 0, 3 to the 0. If you put it into your calculator, I'll write the first one. You're going to write 1. You're going to press the button 1, the caret key. Then say it's the exponent of 0, and then hit enter. And you should get an answer. Then, when you finish doing that, you're going to use the exponent of 1. 1 to the 1st, 2 to the 1st. Then we have exponent of 2, 3, and 4. So, pause your computer, and when you're done, hit play to assess your answers. That will be on the next slide. So, as you can see, here are the answers. Let me just fix the whole slide for you. And we had to come up with patterns. As you can see, the first row, you have anything to the 0 power is equal to the exponent of 1. So for example, x equals 1. X to the 0 equals the whole number 1. Any base with the exponent of 1 is equal to itself. Any exponent base 10 is equal to 1 with the number of exponent zeros. Example, 10 to the 1st is 1 with 1 0. 10 to the 3rd is 1 with 3 zeros. And then you have your base with an exponent of 2 is a perfect square, product of a number multiplied by itself, and then the exponent on base 1 equals to 1. Now we would like you to do this little summary. An exponent is the number of times we're multiplying a base by itself. 2 is the base, 3 is the exponent. So we would like you to complete this chart, hit pause, and then come back and play to assess your answers. Ms. Golden, I'll put something up here on top. four are very easy, or they're fair. And then we have 1/2 to the third, which means 1/2 times 1/2 times 1/2. You could put it in the way you see it, where you put it into the calculator, 1/2 in parentheses, hit the caret key, the exponent of 3, hit enter, and you get 1/8. If you get a decimal, make sure you hit the 2 arrow keys above the enter, and that will change it into a fraction. And also, it's 1 times 1 times 1 equals 1, 2 times 2 times 2 equals 8. Now we would like you to complete this, and then you have to also answer the question, are there any values when a base is negative in your answers to the questions above and explain? I'll give you hit pause, 2 minutes, and then go back to play to assess your answers. So now we're going to assess, and you're going to see some of the answers are starred. So here we go, 5 to the 4th, you know how to expand it, standard form 625. As you can see, I starred the second one, a negative base with an even exponent, and you get negative 216. The way you see it is the way you put it into the calculator. It has parentheses for parentheses. Negative 3 in parentheses is the base, and it's raised to 4, or the 4th power, and you get positive 81. Then you get negative 3 to the 4th. Its base is really 3. It's an invisible negative 1 because there's no parentheses. So you could break it up either way. Negative 3, because you did 1 times negative 3, and then it's times 3 times 3 times 3. Or you write negative 1 times 3 times 3 times 3 times 3, and you get negative 81. The second one is the same rule. The base is 2, it's positive, but the negative 1, because it's not a parenthesis, there's an invisible negative 1. So you get negative 1 times 2 times 2 times 2 times 2 times 2. Or you multiply the negative 1 and the 2, you get negative 2 times 2 times 2 times 2 times 2. And you get negative 32. Next one in expanded form, negative 2 times negative 2 times negative 2 times negative 2 times negative 2, and you get negative 32. As you can see, I started number 2, 3, and 6 to come up with pattern or a rule. The negative base, and here are the rules. You have a negative base, I'm sorry, the small board is not cooperating. Negative base, even exponent equals positive number. Negative base, odd exponent, a negative number. Now we want you to try this out, this next slide. I will give you minutes to pause and then hit play when you're ready. And here we go. Assess yourself. This follows the rule. We have a negative base, even exponent, you get a positive number. This is different. This is a visible negative 1. So I wrote it 2 ways, negative 1 times 9 times 9 times 9 times 9. Or negative 9 times 9 times 9 times 9 equals negative 6,561. And then the next one holds the same rule. I have a negative base and an even exponent, and you should get a positive 117,649. And this is the one where there's the invisible 1. The first one is negative 7 times 7 times 7 times 7 times 7 times 7. Or negative 1 times 7 times 7 times 7 times 7 times 7 times 7 times 7. And you get a negative 117,649. So we would like you to try this next with the fractional basis. Everybody see that? Hit pause and hit play when you're ready. So here we go. Assess yourself. Expanded notation. It's a fractional base. So it's 1/3 times 1/3 times 1/3 times 1/3, or 1/81. The next one is 3/4 times 3/4 times 3/4 times 3/4, 81/256. And then expanded notation for a negative base. It's negative 1/5 times negative 1/5 times negative 1/5. It's a negative base or exponent to get a negative number. one is a negative base, even exponent. I know it's going to be a positive number. It's negative 2 sevenths times negative 2 sevenths, and you get 449. What does a negative exponent mean? Sometimes expressions have negative exponents. 8 to the negative 2, the base is 8. You put it over 1. You do its reciprocal, which becomes 1 over 8, and make the exponent positive. So, and a negative exponent means fraction. So again, put it over 1. So now it's 8 over 1, its reciprocal is 1/8. The negative 2 becomes positive 2, and then it's negative, it's 1/8 times 1/8 equals 164. So now you have to try it, and now we'll go over it. I'm just trying to get the slide there. Here we go. 5 to the negative 2. Put it over 1, do the reciprocal, 1/5, and then turn the exponent positive, and you get 1 over 25. 6 to the negative 3 gives you 1 over 6 to the third. Put it over 1, reciprocal, and you turn the exponent positive, and you get 1 over 2/16. Now, this one is 1/8 to the negative 2. Let me show you, I boxed it off, it's 1/8. You do its reciprocal, 8 over 1, and turn the exponent positive, and it becomes 8 squared, which equals 64. Now, I'm going to tell you to pause, and we want to complete the table. So pause and you play when you're ready to assess yourself. So here are the answers. Assess yourself. And you get 1/4 squared, and it's 1/16. Now you put it over 1, reciprocal, 1/9 to the third, 729. Again, we have to see, you have to do reciprocal work backwards. You get 5, turn the exponent to the negative. And then it equals 625. Sorry, it should be 1 over 625. And then the next one is 8 to the negative 2, 1 over 8 squared, 1 over 64. Here the base is negative. In parentheses, you put it over 1, it becomes 1 over negative 3, and then you turn the exponent to a positive. And you get negative 127. And I'm hoping that you did the fast finisher. Anything to the 0 power equals 1. So 2 to the 0 equals 1, x to the 0 equals 1. So, basically, the summary and step by step. If you see a negative exponent, make believe it isn't there, and calculate the answer as if it was a positive exponent. After calculating your answer, find the reciprocal, and that's your final answer. Right now, I was telling you, put this over 1, do its reciprocal, which would be 1/3, and make the exponent positive, and then it would be 1, b squared is 9. Or the trick is, just take this, pretend the exponent is not negative, then it's positive, b squared is 9. So if you get 9, you put it over 1, and then do its reciprocal. So the next one should be 1 over 1,728, 1 over 100, and 1 over x to the 4th. Again, do its reciprocal, and turn the exponent positive. Okay, so now we want the expanded and standard notation of each. Right now, the expanded notation, try this. We pause and we play to come back to the set. Okay, so we have 2/3. Hold on, I just have to put on the pen. There we go. So 2/3 times 2/3 times 2/3 times 2/3, and you get 16 over 81. Now, this follows the rule I have a negative exponent. Do its reciprocal, it's a fractional base, so it becomes 5 over 1, which equals 5, and make now it's 5 times 5 times 5, which equals 125. The next one is write this fraction using a positive exponent. The base is 3/4. Do its reciprocal. 4/3 and turn the exponent positive. So now expanded form is 4/3 times 4/3, and you get 16/9. So we don't have clippers, we're not in class today, so we're going to do this. Which expression is not equivalent to 5 to the negative 3? So, in pause, completed, hit play when you're ready. So my first step is, you have to figure out what is 5 to the negative 3. Put it over 1, do its reciprocal, which gives you 1/5, turn the exponent positive, and it's to the third power, or 1/5 to the third. Well, that's what our first answer is. They're asking for 9. So this also equals 1/125. B is also not the answer because it is 1/125. This one, 5 to the 0, anything to the 0 power is 1/125. So that's also the correct answer, but it's not the correct answer for this question. But D is incorrect because it is not equal to the whole number 1/125 because negative exponent represents fraction. So D is the answer. So these are a few rules to remember for negative exponents. You should study them. And then I would like you write this using a positive exponent, 4 to the negative 5, and using a positive exponent, -6 to the 6/7 to the negative 3. So we have to follow the rule. Put this over 1. Do its reciprocal, it's 4. It's 1/4. And the exponent becomes positive. So now if you have a hard time doing, it'd be easier to do this, you have to expand it first. So it's 1/4 times 1/4, 1/4, 1/4, or 1/4. You have 5 of them, 1, 2, 3, 4, 5. And then if you're having trouble, just put it into your calculator and figure out what the answer is. And I got 1/1024. Now, you could have put it in as 1/4 to the 5th, and you could have sat there and said 4 times 4 times 4. The next one, using a positive exponent, is a negative, which is reciprocal, and turn the exponent positive. So now it's 7/6, or 7/6, times 7/6. And you should get 343/216. So here are the 3 takeaways we get from the lesson. A negative base, even exponent is a positive number. Negative base odd exponent equals a negative number. Any negative exponent, take the reciprocal of the base and make the exponent positive. Again, negative base, even exponent is your positive number. Negative base, odd exponent equals a negative number. Any negative exponent, take the reciprocal of the base and make the exponent positive. This is the end of the lesson.